Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper trending on X, published on January 29, 2026, about 5 days ago. It introduces a method where strong post-trained models actively guide the pre-training process, resulting in up to an 86% win rate in overall generation quality and over a 36% relative improvement in factuality. The paper is titled Self-Improving Pre-Training, Using Post-Trained Models to Pre-Train Better Models. And as we'll see later, the results are really impressive, suggesting we can prevent hallucinations from becoming deeply embedded in the first place. Figure 1 illustrates exactly how this self-improving pipeline works. It starts on the left by streaming pre-training data, effectively splitting documents into a prefix and a target suffix. The model being trained, labeled here as the policy large language model, generates its own attempts or rollouts based on that prefix. Meanwhile, a strong post-trained model acts as a rewriter to produce a superior version of the original text. Finally, a judge evaluates all these candidates, the original text, the rewrite, and the rollouts, and sends rewards back to update the policy via reinforcement learning. To implement the judge, the researchers design specific templates, such as this safety judgment prompt. It presents the generated suffix to the model and demands a binary safety classification. However, instead of a simple yes or no, the instructions require the judge to first provide reasoning, ensuring that the final decision is grounded in a logical chain of thought before being passed to the training algorithm. So, Table 1 now quantifies the impact of those judgments across 3 key areas: quality, factuality, and safety. First, looking at the top section for quality, the self-improving pre-training method achieves a massive 86% win rate on standard prefixes compared to the baseline. Next, the middle rows show that for factuality, the method pushes the average evaluation score from 44 up to nearly 58. Finally, in the safety section at the bottom, the model attains a safety score of roughly 91, demonstrating that the learned policy successfully steers the model away from unsafe outputs. Moving on to Figure 8, we see how the source of supervision shifts over time as the model learns. The left chart tracks the from-scratch pre-training scenario. Notice how the blue line starts at 0 and gradually rises to about 15%. This indicates that early on, the model rarely generates high-quality text, so it learns primarily from the rewrites or original data. However, on the right, which depicts continued pre-training, the story is different. Here, the rollout chosen rate jumps almost immediately to nearly 100% because the pre-trained model is already strong enough to produce superior completions that the judge prefers. Alright. Table 6 breaks down the ablation study, comparing various training objectives to isolate what drives performance. The top rows show the baselines, where standard pre-training scores about 50 for quality and 76 for safety. In the middle section, methods without a judge, like supervised fine-tuning on rewrites, improve safety but fail to boost general quality. The real gains appear in the bottom section with self-improving pre-training. Specifically, using online direct preference optimization with 16 rollouts achieves the best results, jumping to a quality score of nearly 74 and a safety score over 91. So, Figure 9 visualizes exactly why that rollout count matters, plotting performance metrics against the number of generated candidates. On the left, look at the coherence scores for quality. There is a steady climb from under 70 to nearly 90, as we scale from 2 up to 16 rollouts. The middle chart confirms a similar upward trend for factuality. Finally, the safety results on the right show that adding more rollouts consistently boosts scores, especially in the hatched bars, where the model compares rollouts against both the original suffix and the rewrite. Wrapping up, 2 takeaways stand out. Moving alignment upstream into pre-training effectively prevents hallucinations and unsafe patterns from taking root, rather than trying to patch them later. Furthermore, the results prove that using strong models to actively supervise pre-training significantly boosts base model quality. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.